So we're supposed to find the power series for this function, and we want it to be in the form of some sort of geometric series. It's not quite there because of the x squared in the numerator. But let's rewrite a bit. Let's just make that x squared multiply off to the side, because then we're in the form that we want it to be. Right? Because now we have our variable. Our variable is just 16x squared, not x squared. So this we can rewrite using that, using that power series formula. This is going to be the sum from n equals 0 to infinity of 16x squared to the nth power, right? Because this is like your x in the formula here. So 16x squared is here for x, and it's being raised to the nth power. Or written another way, times. That's 16nx to the 2n. And then to clean it up a little bit more, you're multiplying everything by x squared. So you could just multiply that on the inside here. That's 16 to the nth power x to the 2n plus 2 power, because the powers will add up. So that should be fine. I don't know why I changed from 0 to 1, but that should be from n equals 0 to infinity. That should be fine. I mean, I'm thinking about 16. That could be rewritten like this. That's 4 to the second, right? So that would be 4 to the 2nth power, because 4 squared being raised to the nth power, the powers on top of powers would multiply. So either one of those should be okay. I'm not sure which one WebAssign is going to like. You might like this one better. Okay, so that's what we want here. And then identify the interval of convergence. Let's see, you could use the ratio test. So the next term, I keep saying next term, but that's not really what our textbook says. The n plus 1 term divide by the nth term. We evaluate that limit as n goes to infinity. And it's the absolute value. Okay, the n plus 1 term divided by the nth term. This is going to be 4 to the 2n times 4 to the 2. So the 2n's are going to cancel. I'm kind of skipping over some algebra here, but let me know if you want me to go over this in more detail. But this becomes this, because the 2n, 4 to the 2n divided by 4 to the 2n just makes 1. And a similar thing over here, this is x to the 2n plus 2. So this is x to the 2n plus 4 divided by x to the 2n. That's a bad n. Divided by x to the 2n plus 2, so those powers subtract, so that's going to be x to the second. And when we evaluate that limit as n goes to infinity, now we actually don't have any n terms, so that's good. But it needs to be less than 1. So we got 16x squared. The absolute value of 16x squared needs to be less than 1, so that means x squared. The radius of convergence is going to be solving this inequality. 4 squared x squared is less than 1. You divide 16 from both sides. If you take a square root, I don't know, either way, it's going to be the same answer. X is less than 1/4. But because we're evaluating the absolute value, it needs to be negative 1/4 to 1/4. And then we need parentheses, because if the ratio test, if that limit equals 1, then we have something that's indeterminate, right? We'd have to investigate it further. But this is negative 1/4 comma 1/4 for our interval of convergence, because you solve for that radius of convergence. You got a radius of 1/4, and since we're centered at 0, that means negative 1/4 to 1/4 is our interval of convergence.